Welcome back for the online class. And today we will continue from the previous class in which we were discussed on spatial filtering. Yesterday I made the things very much clear, the principal operation of spatial filtering. Okay, how the 3 by 3 matrix will be slided on an image so that it will be processed and output will be in a filtered condition. Okay. Now, based on the previous concept, we will see few of the numericals. Okay. The numericals will be basically used for filtering concept of an image. There's a two filters are used. One is convolution and correlation. The convolution and correlations are the basic operations to be carried out on an image. We will see the numericals based on convolution and correlation. Okay, this is what the image we are performing operations. Okay, with the image will be represented with F, and the kernel or a window will be represented with a W. Okay. Now, look at this, a simple example. There are the basic operations we are performing. The very first one is a correlation. Okay. Now, in the correlation, this is what there are the two diagrammatic approach. The problem numericals we have shown for you. The left one we will see the correlation. Now, in the spatial filtering we require a image F. Okay. I hope you can see F. Okay, and we require a W. It is a kernel. Okay. Now, it is the size of the F will be depends on like the coordinates, or depends on the size of the image. It will be like a m rows and n columns. But your W will be fixed, or it will be like a 3 by 3 or something like 1 by 1, or it is a 5 by 5. Depends on the operation. Now, what are the example I am showing here? It is one dimensional. One dimension in the sense I'm not moving, okay, the matrix by matrix. I'm just moving, okay, in a horizontal way. Okay, means it's a one dimensional movement of operations, so that how the correlation will be performed. Okay, now you can see in this example, okay, the value of a F will be given here 0 0 0 0 1 0 0 0. Okay, now you can see it is a F is nothing but your image, and its origin is also mentioned at the point. Now the origin, okay, in the left side, what is F? Image. What are the bits of that one? 3 zeros, 1, 4 zeros. Okay, your W will be given with the value 1, 2, 3, 2, 8. It is what the coefficient of a W. You can take any other values also. F is also changing, but the W usually it is a standard. In coming class you can understand this one, Laplacian. Okay. Now you write down in the horizontal way 0 0 0 1 0 0 0. Okay, 1 2 3 2. Okay. Now it is a W. Okay. Yesterday what I told, I am performing a correlation operation. Correlation operation. Okay. We have to slide a W on a F. Okay. The concept of sliding of a W on the F. Then how the sliding will be performed? Okay. Look at this. Now, you write down the first all your image values. What are the image values? 0 0 0 1 4 0 zeros. Okay. Now here, okay. Now you write down the F value. Okay, 0 0 0 1 0 0. What is your W? 1 2 3 2 2 2 8. you take down this one. Okay, 1 2. Okay, now this is your beginning. Okay, this is a 1 here, 1, it is a beginning of a bit for the W and the end of the bit W. Now what you have to do, you take this value W and slide it onto the origin. Okay, means which is the origin of a F0, you slide it here. Okay, now you can see here, when you are sliding here, the 8, there is a 1 2 3 2 8, the last bit of this W, will be taken onto the origin of a F. I hope you understood this one. Okay, now what is the size of the W? Now size of the W is 5. Okay, let us consider is a M. Okay, the size will be M. Okay, now when the size of the W is M here, okay, now here how many bits are vacant? There is a total M minus 1 bits are vacant, means you have to append so many number of zeros in the beginning and at the end of the F. I hope you understood. What is the size here? Here W is nothing but 5. 5 minus 1, that is a 4. There is a 4 positions. 4 positions are appended with a 0. I hope you understood this one. Okay, now when you append at the beginning, similarly you have to append it at the end also. For which one? For F image. Getting it? Okay, now how many number of zeros you have appended? The thing is very clear, because if the size of the W is M, totally M minus 1 bits to be appended. The bits are nothing but a zeros to be appended at the beginning, at the end. Okay, now once you appended this one, okay, all the way you need to be keep here, the origin bit will be, okay, it will be retained. Okay, now we call it as a first step, for the first step of the correlation. Okay, how the data bits will be comes into picture. Okay, now what we have to do, we have to shift a 1 bit right. This is the shifted bit. Shift 1 bit right. Okay, when you shift the 1 bit right here, you multiply the corresponding bits. 0 into 1, 0, plus 0 into 2, 0, plus 0 into 3, 0, 0 into 2, 0, 0 into 8, 0, means you got a 0. This is 0 you got. Means the output from the first shift is 0. I hope you are getting it this one. Okay, now again this is a first shift operation. Okay, again what you can do, you shift 1 bit right. Shift 1 bit right. When you shift a 1 bit right, now this is 1 here. Okay, now when you shift here, this is 8 at this point. Okay, I hope you can see. Okay, now 8 will be at this point. Okay, shift here. Again you shift here, means 8 will be go to the next bit of this one. Okay, in the second position. Okay, there is a second position, you multiply again with the 0 into 8, 0, 0 into 2, 0. I am just shifted with the second bit. 0 into 2, 0, 0 into 2, 0, 0 into 1, 0, means again in the second shift also I am getting a 0 only. Okay, I hope you understood this one. Okay, now 0, this one 0, this is 0, this is second shift. Okay, now what you have to do, again in the third shift, shift these bits. When you shift these bits here, what will happen? 8 will be at this point. Okay, next what will come here? 2. Okay, next what will be that? 3. Okay, next will be 2, next will be 1. Okay, you multiply. Now 1 into 8, because 1 is correspondingly multiplied with 8 here, you will get here 8, plus 2 into 0, 0, 3 into 0, 0, 2 into 0, 0, 1 into 0, 0, means what the answer you get here? 8. It is not the 0 now. Okay, now in the third step. Okay, In the third step, I obtained 8. Okay, I'll write here 8 you got here. When this 8 is slided onto this 1. Okay, again you shift 1 bit. Okay, this is what the shifted bit here. Okay, now this 1 is 1 will be, now 0 will be multiplied by 8. What you get here? 0. 1 into 2, 2. 3 into 0, 0. 0 into 2, 0. 0 into 1, 0. Means all the way, what you get here again? 2. Okay, the result you get here 2. I hope you're getting it now. Again you shift one more bit here. One more bit here. Now what will happen? The 3 will come at this position. When the 3 will be coming at this position, 8 into 0, 0. 2 into 0, 0. 3 into 1, 3. What I get here? 3. Okay. Now again you shift in next one more bit here. Shift it one more bit. So what will happen here? 2 into 1, 2. What you get here? Okay, all the values will be 0. Okay, now again shift it one bit here. This one will be come at this position. So what you'll get here? Means I got here the final answer. That's 1, 2, 3, 2, 8. Like this. This is the final bit position. I hope you understood this one. Okay, how I performed here. Means whenever the W is slided with respect to 1, you are getting an answer. That is the answer 8. Initially, second time 2. 3, 2, 1 means simultaneously when you shift it all the positions. Okay, look at this one. How many positions you have shifted? Okay, you just count it here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. 12 bits, 12 positions you have shifted. I hope you understood this one. Means all the way it took all the way it has been reached. Okay, because you need to be, if you have to reach it to the till the end of a f. Now when you reached at the f here, all the way you get here 1, 2, 3, 2, 8. Okay, I hope you understood this one. Now okay, the whatever the answer you get here obtained is 1, 2, 3, 2, 8. Okay, is the answer what you obtained. Okay, now in this correlation you have to flip this. Okay, you have to flip this. What after flipping, what you get here? 8, 2, 3, 2, 1. This is the 8, 2, 3, 2, 1. Now I have rotated it. Rotated by how much degree? 180 degree. After this rotation you get here 8, 2, 3, 2, 1. Okay, now 8 will go into the beginning, the 2 in the next, 3 middle, 2, 1. Okay, now in this here how many number of shifts you done? 12 shifts. Okay, now what are the obtained result here? 8, 2, 3, 2, 1. Okay, now what you have to do here? You have to append number of zeros. Number of zeros. That is, you have to make it with like a 12 bits. In this here, okay, there is how many number of shifts are there? You get here 12. So you'll end up with there these type of bits, 12 shifts. Okay, if you perform the operation, you will get here the 0, 0, 0, 8, 2, 3, 2, 1, 4 zeros you will get here, because the correspondingly how you are shifting here. Okay, the whatever the result earlier, the results what you performed, if you get this one, you will get this answer. Okay, now what is the total length here? 12. Okay, now in the final step, okay, the final step, the cropped correlation, okay, correlation result, the output has to be same as the length of the f. Okay, I'll repeat here, the length of the output has to be same as the length of the f. Now what is the length of the f here? Okay, now what is the length of the previous C? What is the length of the f here? I took here f without the appending of zeros. Okay, what is the length here? 1. You just count it now. What is the count here? 1, 2, 3, 4, 5, 6, 7 and 8. Okay, now what is the length here? 8. So the output sequence is same as the input f. Okay, now what is this one? What is the total length of the final result you get here? 12. But I should have 8. The what you have to do, the number of zeros to be cropped, equal number of zeros to be cropped from left and the right. You have to crop it. Okay, then how do I crop it here? Look at this one. In this, okay, in this output, okay, how many number of zeros are here in the left side? 3 zeros and 4 zeros here. Okay, what is the length you have to make it? You have to make it with the 8. Okay, you need to be crop equal number of zeros from left and 0. So you crop these zeros. Okay, now after cropping you get here 0, 8, 2, 3, 2, 1, 0 zeros. I hope you understood this one. Okay, this is what the operation of a correlation. You need to slide it. Okay, slide it. After sliding, okay, I'm repeating the steps here. What are the final steps I made it? You need to slide the W onto the F. Whatever the result you are getting, you need to be note down. Once if you got the answer, you have to flip the answer, and after the flipping there, you need to be crop the number of zeros, and whatever the result will be same as the input sequence F. Okay, I hope it's clear. Okay, similarly, okay, I'll go with the convolution. Okay, if you understood this one, okay, hardly it require a minute for you to go through this. Okay, now same here, the same step. Okay, when I say a same step in the correlation, I have flipped my result at the end. In this convolution, we have to flip it in the beginning only. Okay, look at this one here. This is my W. Okay, what is the value? 1, 2, 3, 2, 8. In convolution, we have to flip it in the beginning only. When you flip it at the beginning, you need not flip it at the end for the convolution. In correlation, what we have done here, we have not flipped. Okay, and in the end, whatever the result we have obtained, that we have flipped it by 180 degree. Okay, in the convolution, in the beginning only, whatever the W, you have to flip it by 180 degree. 180 degree means this is whatever the value. Okay, 1, 2, 3, 2, 8. After flipping, you get here 8, 2, 3, 2, 1. Means you have to write it reverse way. Okay, when you write the reverse way, again the steps whatever you have performed here. Okay, look at this. Whatever the steps you have performed. Okay, like you sliding it. Okay, sliding it by one. Okay, the same process if you perform. Okay, look at this one. Okay, I'll just repeat it for a in a short base. Okay, what is the answer? What is the length of the F here now? That is a 8. Okay, what is the length of the M? 5. Means when you took here is the origin. Okay, origin here means it will be taken at the beginning of this one. 8, 2, 3, 2, 1. So how many number of zeros to be appended? M minus 1. What is the value of M? 5. There how many number of zeros to be appended at the left and the right? There is a 4 bits, 4 zeros to be appended. Okay, this is what I have appended. Okay, 4 zeros are appended and 4 zeros at the end are appended, and again you slide it. When you're sliding here, what you get here? 0. Or if you're confusing with how the result you obtained here in the end, you just go and note it. What you get here? 0. Second one 0. Third one, okay, third one what you get? One is 0. Okay, when you shift here 0, when you shift here, okay, 0. Okay, next what you get here? 1 you get. Okay, next what is that? 2, next 3, next, okay, 1, 2, 3, 2. Okay, next here 8. Okay, afterwards whatever the answer is there, you get it all zeros. Means the final result what you obtained. Okay, now final result whatever this is available for you. Okay, now the final result here 1, 2, 3, 2, 8. Okay, 4 zeros here, 3 zeros here. I hope you understood this one. Okay, after multiplying, okay, you will end up with like 1, 2, 3, 2, 8. The right side 4 zeros and the left side 4 0. Okay, now what is the condition here again? The output result, the output result sequence, okay, length sequence will be same as input sequence. What is the length of the output here now? Okay, now obviously there is a 12 you are getting here. 1, you just count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. But what is the length of the output sequence here? Length of the input sequence is 8, that is F. Without appending 0, it's 8. Means how many number of zeros to be cropped here? 2 zeros here, 2 zeros here. What is the result here get here? 0, 1, 2, 3, 2, 8, double zeros. Okay. I hope you understood this one. Means this is what the one-dimensional correlation and convolution operations you have performed on an image, one dimension. If I consider as a two-dimensional, means it will be in the form like a matrix. Okay, this we will discuss it in coming class. Okay. I hope this what the example I took it for you to understood. For the understanding purpose, it is very much clear. Okay. Correlation and convolution. This is a sequence. Okay, this is the operations we are performing much of the time on the image. Okay, it is like what the difference here we have obtained in the correlation and convolution is that in correlation post rotate in the final result, in the convolution pre rotate. Okay, and usually there is no difference between correlation and convolution much of the time. In the digital image processing, both will be in image. On a digital signal processing, you might have studied with the correlation and convolution separately. In image processing, both will be dealt with a same. There is a correlation and convolution, and the output result is also same. Okay, that's like whatever we are getting at. The convolution. Okay, the general term we are using it is a convolution. Okay, for the reference purpose to understanding of a filter. It is a type of a filter. I discussed a filter, correlation and convolution. Okay, this is what the simple concept will be carried out for the full throughout your image processing subject. Okay, I hope you understood. I'll conclude the class. Thank you.